Today's episode is about the Flexiforce sensor. In this episode, I will show you the easiest way how to calibrate Flexiforce sensor. We will be measuring some known weights with this sensor. I personally don't recommend using force sensor for weight measurement. For weight measurement, load cell is the best choice. I have a very detailed tutorials on weight measurement using load cell and HX711. The link is given in the description if in case you want to watch this tutorial. In today's episode, I'll be using weights only for the demonstration purposes. This episode covers the extreme basics, while in the upcoming tutorials, we will be using this sensor in security-based projects. We will also be using this sensor in plastic injection molding machines for pressure monitoring. We will also be using this in robotics. So make sure you subscribe right now so that you never miss any of my upcoming tutorials. Let's get started. The components that we will be needing for this project are: number 1, Flexiforce sensor or force sensitive resistor FSR. Number 2, a 10K resistor. Number 3, 470 microfarad capacitor. Without a capacitor, the values fluctuate a lot, but using a capacitor will result in stable values. Number 4, breadboard. Number 5, Arduino, and finally number 6, jumper wires. The red wire is connected with the 5 volts, the gray wire is connected with the ground, and blue wire is connected with the analog pin A0. These components can be purchased from Amazon. The components purchase links are given in the description. A Flexiforce sensor is also known as force sensing resistor, is a material whose resistance changes when a force, pressure or mechanical stress is applied. They are also known as force sensitive resistor FSR. The sensor, as you can see, has 3 legs. Middle one is not used. This is the effective area of the sensor where the force or pressure will be applied. To apply the force or pressure exactly at this area, I cut a piece of hard rubber in a circular shape and fix it using a hot glue. Now our sensor is ready. Flexiforce sensor is connected in series with a 10K resistor. You can try some other resistors like 1 mega ohm or 3.3K. If you want to measure high force or high pressure, the Flexiforce sensor and the 10K resistor makes a voltage divider. This way, for different forces or pressure values, we will get different voltages. From this voltage variation, which is due to the force or weight, we can calculate the weight in pounds or kgs. So make sure you have some known weights. I have 1 kg and 3 kg weights, which I will use for the calibration. A 470 microfarad capacitor is connected in parallel with the 10K resistor. You can use a small value capacitor. The purpose of this capacitor is to stop the voltage fluctuation and get stable values. We will read these voltages using the Arduino's analog pin A0. Once again, if you want to measure high pressure or weight, then use a small value resistor. First of all, insert a 10K resistor into the breadboard. Now insert the Flexiforce sensor into the breadboard. The Flexiforce sensor and 10K resistor are connected in series. Now connect 5 volt with the other leg of the Flexiforce sensor. Connect the blue wire which is coming from the A0 pin of the Arduino between sensor and 10K resistor, and ground with the remaining leg of the 10K resistor. And finally connect the capacitor. Now our interfacing is completed. Now let's discuss the programming. Float CF is equal to 19.5, which is the calibration factor. This value will be used for the calibration. I will practically show you during the testing what happens when you change this value. Integer FFS1 equals A0. Flexiforce sensor is connected with the analog pin A0 of the Arduino Omega. The same program will also run on Mega. Integer FFS data is equal to 0. Float V out. Vout is a variable of the type float and will be used to store the voltage. This voltage represents the force or pressure. As you know, my friends, every Arduino and Mega program has at least two functions, which are the void setup and while loop function. The void means that this function is not returning any value, and the empty parentheses means that this function is not taking any arguments as the input. Serial.begin 9600 activates the serial communication. This is a built-in function and it takes only one argument as the input, which is the baud rate, and it's in bits per second. Unlike serial.begin, pin mode is also a function. It takes two arguments, the pin number or pin name and the status, which can be input or output, as the Flexiforce sensor is an input device, so that's why it's set to input. Then starts a while loop function. FFS data is equal to analog read FFS1. This instruction simply reads the voltage available on the analog pin A0, the voltage which is coming from the voltage divider. Vout is equal to FFS data into 5 and then divide by 1023. This instruction is used to calculate the voltage. Vout is equal to Vout multiplied by the calibration factor value. Calibration factor is multiplied. Now Vout consists of the final weight value. These instructions are used to send the value to the serial monitor, and then there is a delay of 100 milliseconds. I have already uploaded this program. Now let's watch this project in action. Before you start the testing, make sure you have some known weights. Right now I have two weights, 1 kg and 2 kg. First of all, connect Arduino with the laptop. Open serial monitor. As you can see, currently the value is 0.00, as there is no force, pressure or weight. First I place 1 kg weight. As you can see, the value is 1.048, which is pretty close. You can further adjust this value by increasing or decreasing the calibration factor value. Now let me place a 2 kg weight. As you can see, the value is pretty close. Now let's see what happens when we change the calibration factor value. This time you can see the value is increased to 1.789. Now for the 2 kg weight. We are getting wrong values. Now let's again change the calibration factor value back to 19.5. So this is how the calibration factor value affects the final values. I hope you liked today's episode. Like and share this video with your friends. See you in next episode, and thanks for watching.